Hey everybody, and welcome to another JASP tutorial. What do you do if you end up with two separate groups that need to be compared? You want to know whether or not they come from the same population or if they belong to different populations. You can infer that using an independent samples t-test. Oh boy, that sounds like fun, so let's do it. So basically, very quick overview of what we're talking about here. This is a data set that's looking at sleep deprived schedules versus normal sleep schedules and whether or not that affects GPA and how often someone studies for an exam. So what you see here for participant, this just goes down to 152. I have 152 participants. For group, I have, you'll see that this person says normal because they had a normal sleep schedule. Deprived means they had a deprived sleep schedule. So normal being about 8 hours, deprived being about 2 to 3 hours a night. GPA, self-explanatory, and study hours, letting you know how many hours they study before an exam. So again, this is a two-sample t-test, also called an independent sample t-test, because we're looking at two separate samples. You'll note that this participant doesn't participate in both the normal and deprived group. They only do one, and that is what makes this special, what makes it different than the other t-tests. So you can hear my cat, who is not too happy about independent samples. She prefers ANOVAs. We'll cover that in another JASP tutorial soon. So the way we're going to analyze this, we're going to go to t-test. When you go to t-test, you're going to go to independent samples, and this interface should look very familiar to you. But the difference here, and this is where things get a little bit tricky, is the group variable. You need the grouping variable. I have that marked very easily as group, but basically you're looking for a variable that is going to specifically tell you what group your data belong to. So I'm adding group right in there, and then I'm going to compare that across GPA and study hours. So I do that, and automatically JASP has told me what differences there are, if any. And so very quickly I can interpret this and then kind of play around with some of these functions soon. But basically GPA letting me know that according to our p-value, yes indeed, it looks like there was a significant difference, that this is below 0.05, so we're going to reject the null hypothesis. It seems that people with sleep-deprived schedules are going to have lower GPAs than people who don't. Sorry about that. Bad news. I hope you're not watching this video at 3 a.m. So if we look over at the study hours now, you'll see that study hours, the p-value is greater than 0.05, so we will fail to reject that. We will basically assume that that the normal and the deprived students are basically studying the same amount. It's just that their GPA is different. That's kind of how you interpret this, but you got your t-value here, you got your degrees of freedom, which is just going to be your total sample sizes after you add them together and then subtract by 2, and then your p-values here. Now, let's have some fun. So you can come over here and you can see all the different kind of parameters you can mess with. If I assumed that these came from populations with very different variances, so you weren't sure about the homogeneity of variance, you could select the Welch test, and this is going to hopefully correct for that. You can see that our data are pretty normal here. You're seeing that these values are basically identical, which basically means that we have normal distributions in both of these data, which is really good, very rare, but very good. So we feel pretty good about that. And if we wanted to, we could use the Mann-Whitney test, which is going to also try to calculate this using non-parametric analyses. But for most intents and purposes, you're going to want to stick with the student's t-test. That's the industry standard. We can check for normality, and we can check for homogeneity of variance. So we can check for normality here. What I'm looking at here is looks like that the study hours might not be normally distributed. It does appear that it has fine homogeneity of variance, but we can see here that we are rejecting the p here. We cannot say that this is a normally distributed variable, which might be cause for some concern. For me, it doesn't. I'm not super concerned about it, but in case your professor ever asks you about that, you can find that information right there. So I'm going to deselect those now. And I forgot my favorite thing to check. I love hitting descriptives. I love getting a lot of data about these things. And so you can see how many people were in each group. You can see that we actually have unequal ends, that these sample sizes are different sizes. You can see the means. So for the deprived group, we have a mean of about 2, a GPA of 2. And then for the normal group, we have about a 2.45. So about half a letter grade of a difference here. And then you can see the standard deviation and standard error for those values. Let's see, we can find the effect size, and we can specify what kind of effect size we want. I prefer Cohen's D. That's what I was raised on, so I'm going to go with Cohen's D. And if we want to, we can also specify the confidence intervals and the parameters around that. So I got the confidence interval here, and just a reminder that if your confidence interval, if 0 is included in that confidence interval, then you need to reject the null. If it's included in that interval, then you cannot reject the null hypothesis. But here we are seeing that GPA 0 does not fall within that confidence interval, whereas for study hours it does, which is reflected in our p-value here. If you like p-values, you don't need to go through all this trouble, but if you don't like p-values, then you can find the confidence interval here. That's pretty much it. So pretty straightforward. If you want to play with the plots, you can, but they don't always look so good. This one actually doesn't look super bad, but I don't know. Basically, the way you interpret this is that, hey, it looks like for GPA that it goes up between deprived and normal versus study hours, which are mostly the same. But again, I don't really like these plots because I am a snob when it comes to plots. Alright, thanks for tuning in, and I'll catch you in the next tutorial where we will talk about ANOVAs. Bye.